I mentioned we had a luxurious 4:30 in the afternoon launch, and I'm used to going down there real sleepy-eyed at this particular time because I'd been for a week prior getting my circadian rhythm adjusted, but with a 4:30 in the afternoon launch, our required wake-up time was 7:30 in the morning each day, so we didn't have to do too much in the way of sleep shift. We were shifted for this flight when we were assigned to it about 9 months prior. You can see Jerry there and everybody getting in their suit. We're getting Susan's hair stuffed in that helmet there. Carl always takes these things in stride and finally walk out, and it was nice to see. It was a work day and in the afternoon about noon, and we had a lot of people out there wishing us well, and that's always good to see. Blaine can tell us about the launch.
Well, it's like Dick said, it's in the afternoon, and it's a different sort of view from the cockpit because the sun's not beaming in on you, but you can see Dick here just before we launch, and about 10 seconds before the engines start, we don't feel this so much, but the water starts going, the engines crank up, things start shaking and rattling, and you see the twang here, and really good view of that, and all of a sudden those solids light, and you know you're going somewhere for at least the next 2 minutes, and about instantaneous 1.8 G right off the pad. But from all accounts of our family and friends watching, it is a beautiful launch with right after the rainbow, as Dick mentioned earlier. But here we are on a roll program, putting us head down on our 57-degree inclination and heading up to our orbital altitude of 140 miles. We're going about Mach 1, just for those of you who don't know, at about 20,000 feet and about 20 seconds after liftoff. And you can see this graphically here. In the next couple scenes, you'll see the shock wave come across the orbiter as they're going through the Mach there. Quite a pretty sight. As Dick mentioned earlier, we must have launched at the only hole in the clouds there in Florida, so we were real glad to get airborne and apparently real lucky too, based on the way the weather patterns were shaping up. And you can tell by the smoke stream that very little wind shears up at higher altitudes. A pretty calm day as far as that goes. We'll welcome relief at about 2 minutes in the flight. The solids separate, and now we're on the 3-minute engines. And then, like we said before, everything worked just perfectly. Just absolutely a beautiful launch, and nothing to complain about.
And here we have a little bit better view of what we see as we pass overhead with light. What we had to do is get it activated right away. Dick put on his hat to do that. Carl ran down to the middeck. We had our light PGSC on the middeck because we didn't anticipate needing it very much, so we got it hooked up down there because we had so many other PGSCs that we had to keep up on the flight deck. But once again, here's where the laser comes out of the pallet and comes down and bounces off the clouds or the other particles that could be in the atmosphere, comes back and is collected on board the light. This showed up a little bit better earlier, but this is the center of a hurricane called Melissa, and this is the volcano that we showed a picture of earlier. We got some pretty good views looking from the side. Then overhead you can see the dust that didn't go very high in the atmosphere. It stayed pretty low. These clouds went up to about 60,000 feet, and once you got and saw it off on the horizon, you could see the vertical relief. And this is going off to the west, and this is the low altitude winds carrying some of the dust off to the east. We got the camcorder all ready to go. There was a couple of unique things we did with light, and then we did these cross tracks and landmark tracks where we took a certain spot on the landmark track. This happens to be in the Gulf of California. We're tracking this spot right here as the orbiter goes through about a 60-degree roll maneuver, and we tracked the same spot as we went over the top so the investigators could tell the difference in the surface reflectance of their laser at different angles as we passed overhead. Fortunately, it was clear.
Here's a good overview of how the SPIFEX experiment operated. We basically grappled it while it was on the starboard sill, and then from the starboard sill we went into motion with the arm from that point. This is a scene of myself flying the arm, but again I'll mention we all traded roles around. Mark here is operating the PGSC, and we had 100 test points, as it turns out, from the time we launched to the time we landed. We had expected to get 86, but because of the crew coordination we managed to develop, we got more than that when they sent up the extra test points. Here's a time-lapse photography of the arm in motion. This is the business end of SPIFEX. That's where the load plates and pressure sensors are. In addition, there's also a small camera on that end of SPIFEX, a view of which you're seeing right now. And this is the one thing we regret not having more downlink TV where we could show you some of these spectacular scenes of the orbiter. This is the countdown to Blaine doing the firing. And again, we did this 100 times and got just excellent data from all around the orbiter. We went probably over to 5 or 6 different jets to collect that data.
Susan celebrated like that on every one of those firings. This is a combustion experiment that's called SSCE, and there's a little piece of paper as a fuel inside a chamber right there, and that chamber is filled with oxygen at 2 atmospheres and, with air at 2 atmospheres, but the oxygen content is 50%. It's a large test matrix. This is about the 8th time this experiment is flown, and it'll fly a couple more times.
As I said, running was a pleasure. It felt like you were back on Earth, and just a tremendous treadmill, and I'd say from the waist down, it just felt like you were running normally back here, good heel strike, great dynamics.
Okay, this is me talking to one of my many boyfriends on the SARX. Managed to talk to, I don't know, probably 40 to 50 different people, as it turned out, by the time it was all said and done. However, when I wasn't discussing SARX, I was operating the arm, getting the Spartan out and deployed. This is a night scene of that, bringing the Spartan out of the berth position. It was behind light, and so we had to rely on the Palo Bay cameras in order to get a good visual bead on the Spartan as it was coming out of the V-guides. And moving on, I think since this is the deploy sequence, here you'll see the arm actually releasing the Spartan and backing away. What you won't see in this footage is a confirmation that Spartan is in fact turned on and its brains are working. About 2.5 minutes after we did the release, it did a pirouette maneuver that we were able to visually see both out the window and through the end effector, and we called down to the ground that that pirouette had in fact started, which was a good feeling for the ground that the Spartan was working properly as it began its 48-hour mission. And there's another view of Spartan just before Dick does the SEP sequence, and we begin to back away from it. Again, the view of that thing was just spectacular with the Earth in the background. After we left it, we did not really see it again until we began the rendezvous sequence. It was out of our field of view.
And this is the rendezvous sequence. Rendezvous is a very exciting time for the entire crew. Everybody has a job to do and kind of a little compartmentalized areas of responsibility. Dick does the close-in flying, Blaine did most of the burns, Susan was doing a lot of ranging with the radar, and I was essentially the cockpit worrier. We got real close to this thing after the 2 days, and it's a continual monitoring to try to get close and using various sensors to get up there. And once we use all the sensors at our disposal, be it radar, star trackers, or lasers, handheld or Palo Bay mounted, then we can close in on this thing, and Susan does a great job of just reaching right up there with the arm and snatching it.
Tasks of daily living. Mealtime's always fun, and trying to feed Mark is always a challenge. You have to protect your food locker at all costs. And there we have the dirty dog Mark eating one of his favorite foods, the hot dogs.
Wiener dogs.
You make a lot of trash, and this is our trash compactor. Carl doing the duties here. Usually we delegate that to Blaine. I'm trying to get a little bit more of a workout. It's really tough doing push-ups in zero gravity. And you'll see Carl just kind of float off. Getting Blaine into shape took a little work. We had to whip Blaine into shape, and then we tried to make him speed up. Tried to keep everybody in good condition.
And here we have Blaine getting all his cameras together because we got to the real meat of the mission. We were going EVA. All the other constraints were out of the way. It takes a while to get everybody in their suits. You start almost 3 hours before the actual battery on time. You have 50 minutes of that as a pre-breathe time. The fortunate thing about zero-G is you can go upside down, right side up. The 300-pound spacesuit all of a sudden becomes part of you, and it feels very, very comfortable. Once we got all the airlock ops done, you come, scooting out of the airlock, and it's very natural, for the people here that may work in the WETF or other things. You feel like you're right back in the WETF, especially when it's dark and you can't see the Earth. You look around the Palo Bay, and it has the same feel. I came out. All I do is hook up some tethers, and then Carl comes out. Right after that, you can see we've got our lights on because it is darkness, and we did a little bit of a translation here before we actually flew safer. I actually was so anxious to get flying, I only went halfway down, down the side, came back, and started to fly. The first thing that we did was do a little familiarization maneuvers, and then we did a GN2, a gaseous nitrogen calibration, to make sure that the fuel we were using in orbit was very comparable to what we did in training. The SAFER unit itself is just the bottom part of the backpack. You can see it right in there. And when we got back after the GN2 calibration, we found out that the consumption was exactly as we planned. So I got to do a few optional maneuvers, and all I did was go in front of the windows and do some rolls and yaws to try to see how much cross-coupling there was when you weren't using the attitude hold feature of the SAFER. So what I did here is I put in a roll, and you can see that I'm starting to yaw a little bit as I go around. If you did without attitude hold, almost every axis has some cross-coupling, and although you could probably fly like that, it'd be very difficult, possibly if you were tumbling, to be able to fly out without using the attitude hold. Here we see I'm doing a little bit of a yaw, and the whole this whole portion of it took about 15 minutes, and right about now I'm running out of gas. We had a bingo fuel of 25% of our nitrogen, so as soon as we got close to that, we got oriented. Carl, you can see down there doing some of his setup for the next set of maneuvers that we're going to do. And whenever the person wasn't flying SAFER, the other person was always doing setup, tear down, tool evaluations, things of this nature.
This is another one of our demonstrations called a rescue demonstration. This is the part of the flight test where we want to make sure that the SAFER unit itself will do its job as intended. So as you can imagine, if you were on a space station or a large structure where you accidentally flipped yourself off under some tension or a tether broke, something like that, and you were not attached, you might be tumbling and translating at the same time. So here's a picture of me spinning Mark up, I believe, and and then Mark, after a certain delay, turns the SAFER on as if he were activating it in an emergency, and then trying the attitude hold, make sure it comes under control, and flying back to my position. So I'm on the arm, Susan's controlling the arm. You can see the arm right there moving backwards, simulating there's the tail right there, there's the arm moving backwards. You can see that it's simulating a translation of the crew member. So the crew member right there stops his rotation, finds his target, and then translates on back. We did a build-up technique to make sure that we wouldn't stress the system originally, and as time went on, you can see that the crew member out here, he's flying back, the arm is continuing to move laterally, and he now has to make a closing rate, stop the opening rate and gain a closing rate and fly on back to the target right here. This is not very difficult to do unless you happen to stop when you turn on your attitude hold, staring at that stuff out there, in which case then you don't know where you are and you have to continue to rotate or rotate either in pitch or in yaws, my two favorites, to try to find your target again. Once that's done, you can see the earth limb coming into view here. We practice all this in a training facility here called IGOL, which has virtual reality. It was a very, very fine system. The people there were very enthusiastic and helped us a whole lot. Every time we made a slight suggestion on an improvement, the next time we showed up, it was there. We were very favorably impressed by this facility. Also with the WEDF, I can't go without mentioning that. The WEDF folks were all right there ready to help us. We had, I think, 9 WEDF sessions to practice all these setups, etc. This is one of the refuelings. The operational unit will not be refueled, but we refueled it 7 times, I believe. There is that you, Mark? I think, well, one of us who is flying the SAFER right there, and then the other guy sits in the foot restraint and refuels it through the gaseous nitrogen hose, which comes from the orbiter.
This thing flew even better than I could have dreamed of. We did, as Carl said, we did the training in virtual reality, but going up the arm, we had to stay, our target was to stay about a foot away and have the same up-down position of the arm relative to your chest, and we flew up to the corner, made the corner, and the thing just did perfectly. You couldn't have asked for a better system. What we were trying to do here is simulate that, let's say on space station you fell off, but your nearest thing is solar rays, and you don't want to go over and grab the solar rays, so you may have to go up, maneuver around some solar rays, or some other portion of the the space station that you can't touch and get to a place on the station that's acceptable to grab a hold of. So we would just wanted to see how well the unit would fly. So we went up to the corner, turned around, looked down into the payload bay, and in the meantime, Carl was down there operating a lot of the different tools that we had taken up that we're getting ready for space station. You can see the shadow, kind of running across my back. I didn't have to work, too hard to maintain the position as we were flying down into the bay. And Carl, in just a minute, does almost the exact same thing. But it sure was a pretty sight. It was hard to concentrate on the arm when you had that beautiful view of the Earth passing underneath, and you really get the sensation of speed when you're out there and you're looking away from the payload bay.
Okay. This is a completion of the precision approach. Now, these precision approaches that we're talking about, we go up this arm here, back down there, go back up to here, and then fly back down towards the aft windows. And the reason we're doing that is to flush out any handling qualities problems which might be exhibited by a bang-bang control system, which this is. There's the controller right there. There is one handle right over here, and it's either on or off. So these are typically these are non-conventional control systems, and generally they have what's called a flying qualities cliff. If you turn the pilot's gain up well enough and the task is demanding enough, then you could reach that cliff, and that's what we were trying to flush out. Fortunately, we didn't see any. So here's, I've just left the arm here and trying to fly back down to the payload bay windows, and you'll see that it's a pretty slow process, but there's another portion of it right there. Furthermore, we wanted to test to see if we had to mount this hand controller or we could hold it in our hand. So in a moment here, you'll see that I've taken the hand controller off of my suit, and I'm just holding it in one hand and flying it with the other hand to see if it was controllable. There's another view coming down from the elbow camera. You can see this view coming down, and my target is right there, trying to fly as steady and as straight as I can. And once I reach this point here, hover for 30 seconds. So here's from inside the cabin. I think Blaine was taking this picture. You can see that I'm holding the hand controller right here and flying it right there.
Just a quick note about some of the other activities that went on after the EVA. We had FCS checkout, which is something that's standard for every flight. Before we come home, we want to make sure that all of our instruments are working, our jets are working, and we also want a last opportunity to say hi to Mom and Dad. And after that, it came time for the deorbit prep activities. This is basically getting the orbiter ready to come home. We stow all the things we don't need, and of course Blaine he earned a great nickname on this flight because he cleaned all the time. It was Liquid Blaino.
You said you wouldn't say that.
And yeah, I know I told you I wouldn't say that, Blaine, but it's so appropriate because he really did do a great job keeping everything clean, because if you don't keep the orbiter clean, it really does eat your lunch.
Well, this is the final. We knew we were going to land this day, and I always like entry day because that's also let's be nice to the commander day on the shuttle. The other guys will do anything I want, and all I have to do is ask for it, and they were really great. And so, but the other side of it is then I have to turn their niceness into a nice landing. Unfortunately, we had bad weather in Florida. I was looking forward to getting back to the Kennedy Space Center and landing there, but the weather just didn't support that. So at the last minute, the mission control team, after our cryogenics had gotten down low enough that we could have stayed up another day, but it would have put us down to uncomfortable levels. So we opted to go to Edwards Air Force Base. This is on final there at Edwards, and you probably could discern that we did a small aerodynamic set of maneuvers with the elevons and the rudder there to try to characterize what the control capabilities are of those devices, which later might help us open up some of our crosswind limits for launch and landing. It was a real smooth day. I understand the shuttle training aircraft was getting thrown around quite a bit from the turbulence there, but you didn't feel that at all in the orbiter. It felt like a rock-solid, steady day there, and it was just a question of picking up the runway, and Blaine put the gear down at the right time, and then it was just a question of letting the orbiter stay out of the way of the orbiter because it can land itself. And so just give it a few inputs so it knows where to touch down on the runway. The drag chute came out right at the initiation of derotation, about 10 knots faster than my previous experience, but we're opening up the window of that particular device. And then, of course, the most important thing is to steer back to the runway center line before you stop for all the photos that are going to be taken. 60 knots comes by, and Blaine will jettison the drag chute. And this is about the point where you've been happy. At least I'd been just ecstatic for the last 11 days because it's been a great flight with a great bunch of people, and now I suddenly realized it was over. But that's the way it is, and it's nice to be back to here to Houston and see all your smiling faces. And thanks for giving us the opportunity to fly such a great flight, such as STS-64.